Hello and welcome to today's math lesson. Today we are in chapter 9 and we're going to be talking about lesson 9-4, 5, and 6. And so we're going to do some introduction here on trigonometric ratios. So ratio, remember, is always going to be a comparison of two things. So something like A over B. Have you ever wondered on your calculator what these three buttons stand for? And what they stand for, it's not sin, it's actually sine. And then the cos is cosine. And the tan is tangent. And these are all very specific ratios in right triangles. So these work for any kind of right triangle, whereas the ones we were studying before were 30, 60, 90 triangles and 45, 45, 90, that they are always in the same kind of ratio. Well, that's the same thing that happens here. Sine, cosine, and tangent, mathematicians found out that if you make a right triangle and if you do the ratio of sine for no matter what size triangle, similar triangles, but the angle measures are the same, then we come up with certain ratios. So in this triangle right here, whether you have this size of triangle or you have a similar triangle that would have the same kind of degrees, so still a 23-degree angle right here, but now let's just say this side is 2. Okay, well the side, what happens here is these sides are in the same ratio no matter what if this is a 23-degree angle. So if I get one that's really big and I still have a 23-degree angle here and I call this side 10, the sides are all still in the same ratio. So what is that ratio here? What did mathematicians find out? And so there are 3 different ratios that they found out here. So whenever we do this, it is first and foremost a right triangle. And we are always talking about from these acute angles, either angle A or angle B. You never take these ratios from the right angle itself. Okay, you always do these from the actual acute angles. So there's 3 different ratios that we have in here. And one of these ratios is something called sine. So let's take sine is going to be the opposite leg over the hypotenuse. So sine is going to be the opposite leg over the hypotenuse. So you can see that they have the ratio of A over C. And then now we can do the sine of B. So from this angle B, it's the leg opposite, which is going to be B over the hypotenuse C. So they have this ratio, B over C. So we're always taking the sine of an angle is opposite over hypotenuse. Okay, then we also have ratios of cosine. So now what are our cosine ratios? Now when we do cosine, we're talking about the adjacent leg. So let's take this one. And the adjacent is the leg, not the hypotenuse. It's always the leg. The adjacent leg, which in this case would be over the hypotenuse C. So if you see adjacent over hypotenuse, cosine of an angle is adjacent over hypotenuse. And you're like, I'm confused. What do I use for adjacent? Do I use the C or the B? Well, it's over the hypotenuse. So you're not going to use hypotenuse over hypotenuse. So it's going to be leg over hypotenuse. So that's we're getting B over C. And then again, you can do it from your angle B, which would be adjacent over hypotenuse. So we get A over C. And the third one that we just mentioned on that last page is tangent. And the ratio of tangent is opposite over adjacent. So tangent is opposite over adjacent. So tangent of an angle is always opposite over adjacent. All right. So let's see here. Sine of C. Okay, sine. So here you can see where you hear people say so, ka, toa. So stands for sine is opposite over hypotenuse. Ka, C-A-H, is cosine, is adjacent over hypotenuse. And then toa is tangent, is opposite over adjacent. Okay, so these are the three ratios that you're going to be using. So let's look at the sine of C. So if we're at C, this is this angle here, and we're going to be using opposite. So we go to the opposite side over the hypotenuse. So the sine of C is going to be the ratio of 4 over 5. Tangent of A. So let's start at A, and now we want to do tangent. So we're going to do the side opposite, which is 3, over adjacent, and the adjacent side is 4. Okay, why don't I use the 5? Because the 5 is the hypotenuse, and if I want to use the hypotenuse, I'm going to say hypotenuse. Otherwise, we are using the legs. All right, let me get rid of these here, and let's do the cosine. So the last one here is the cosine of A. So go to A, and the cosine ratio is adjacent. So what is adjacent to this one right here? Don't use the hypotenuse. Adjacent is 4 over the hypotenuse, which is 5. All right. So ka, toa. All right, so what expression is equal to the cosine of 19? So the cosine of 19 would be the sine opposite. No, sorry, that's not right. Cosine is adjacent. So we're going to use adjacent over the hypotenuse. Adjacent over hypotenuse. All right, special right triangles. Okay, we have a special right triangle, and so this first one here is a cosine of 60, so that's the pink one. So this right here must be my 30-degree angle, and this one right here must be my 60. Now, it does not matter what you start with here, just pick a number, any number, no matter what you pick with. So if I pick the short leg to be 3, I now do not have a choice. If that short leg is 3, then this hypotenuse is 6, and the long leg is going to be 3 root 3. So what is the cosine of 60? Okay, they want us to write it as a fraction. So the cosine of 60 would be the adjacent over hypotenuse. So the adjacent side is 3 and the hypotenuse is 6. So this would be the fraction 1/2. Now some are like, well, wait a minute. How do you know that it's 3 over 6? Well, let's just pick a different number. So let's put 13 in here. Well, if that's 13, then that makes this side 26, and that makes this 13 root 3. So let's still do adjacent over hypotenuse, and what's that going to reduce to? Okay, every single time. And you guys could just grab your calculator right now, and you know that 1/2 is 0.5. So hit cosine and then hit 60, and this should come out to be 0.5. Okay, we're not, but they want the ratio as a fraction, so they want 1/2. All right, so now what's the tangent of, oops, I'm gonna get this erased here. So the tangent of 30. All right, the tangent of 30, remember tangent is opposite over adjacent. So here's my 30, here's my 60, and what did I have in here? 3 root 3, and then I said this was 6. Okay, so from 30, the side opposite is 3, and the side adjacent is 3 root 3. Okay, now we always have to simplify. So 3 over 3, that just reduces to 1. Now I have to multiply by root 3 over root 3. So I get root 3 over 3. So the ratio is root 3 over 3. Now grab your calculator and find out what this decimal is of root 3 over 3. So just punch it in, and what do you get? And you probably get something like 0.577. Well, now grab your calculator and hit tangent 30. And what does that decimal come out to be? And you see their ratios are exactly the same. So it doesn't matter what size triangle, but the ratios are going to come out to be the same. All right, let's get this last one in here. So the sine of 45. Okay, so this one's going to be your 45, 90 triangle. And let's just make this 5 and this 5. So this is 5 root 2. All right, the sine of 45 is going to be opposite over hypotenuse. So 5 over 5 root 2. Okay, let's take the 5s. They cancel. And now we got to multiply by root 2 over root 2. So it looks like I'm getting root 2 over 2 would be the fraction that they're looking for. So again, take that decimal. Take your calculator, square root of 2, divide by 2, and you're going to get a decimal something like 707. Now use your calculator and hit sine of 45, and you're going to get 0.707. Now, occasionally what happens here is when you're doing these things, you have to make sure you're in degree mode. Sometimes your calculators default to a different mode, so look into your calculator and make sure that it is in degree mode. So if you have questions, you might have to Google it or ask when you're in class, but please make sure that you are in degree mode for doing this. Okay, so now if we do cosine of 76, this decimal should come out to be something like 0.24192, and it goes on. Okay, so if you just round it to 2 places, the sine of 8, so some calculators are different. Some you hit sine, then you put in the 8 and hit enter. Some of them you hit 8 and then sine. So it kind of depends on your calculator, and that decimal should be 0.14. And then your tangent of 82 should come out to be 7.12. Okay, again, degree mode is the big thing here. Okay, so now how do we actually solve a problem that is written like this? Okay, we want to know what BC is. I want to know what this side over here, BC, is. So I'm just going to call that X. So from here, I know an angle, and what do I know? I know this side, which is the opposite, and I know the hypotenuse. So now look at your ratios. Is it sine, cosine, or tangent that does this ratio? So we're going to take the sine of 23 is opposite X over hypotenuse 4. Now really what this is just a proportion. We can just put a 1 underneath here, and we're going to solve this by cross multiplying. So we're going to take 4 times the sine of 23. These have to go together, and this equals X. Be careful, because if you write it like this, sine of 23, what happens is a parenthesis comes up and you hit 23. So if you just hit times 4, your calculator is going to multiply these two together and then do the math. So make sure that you put a parenthesis after this and then times 4. That's why I have a tendency to put that number in front first. So I'm going to hit 4 sine 23, and I got X to be equal to 1.56. So if we're going to round to the 10th, we would say 1.6. Okay, so what did I know? Opposite over hypotenuse. All right, let's find this. Okay, we got 53, and what do I know? I know this piece right here, which is the adjacent side, and this piece is my hypotenuse. So what ratio is this? So this is going to be the cosine of 53 is adjacent over my hypotenuse. So now I'm going to cross multiply here. And so what ends up happening is you take the cos x times the cosine of 53 equals 27, and I'm going to have to divide by the cosine of 53. So our answer is 44.9.